Okay, let's talk about shapes of distributions. So I mentioned before that a distribution means the values of the variable and the frequencies of each of those. Things like, are there a lot on the high end, a lot on the low end, a lot in the middle, things like that. So to start off, a unimodal distribution has one well-defined peak, whereas a bimodal distribution has two well-defined peaks. Now we'll look at all of the examples of these fairly soon. A uniform distribution has all the bars about the same height. In other words, it has no well-defined peaks. So be careful, these words are sort of similar, unimodal versus uniform. But remember, think about unimodal meaning one mode or high point, bimodal meaning two high points. Uniform, I don't know where that one comes from, but it's different. And then in addition to that, we have whether something is symmetric or skewed. A symmetric distribution kind of looks about the same on the right and the left, whereas if it's skewed right, it has a tail towards the right, and the mean is greater than the median. If it's skewed left, the tail is on the left, where the mean would be less than the median. So let's go ahead and look at some examples of these. Our first example comes from this website, which was some sort of research paper, where they were nice enough to include histograms of the height distribution of adult English soldiers in America and adult Irish soldiers in America. And this, if you look at the URL, was the early 18th century. Now the data here is kind of weird because they recorded it every quarter inch is where the histogram goes, but most people don't report their height down to the quarter inch. They either report it as full inches or half inches, and only a few people in these tiny bars here or the missing bars report it to the quarter inch. So if you look at this distribution, there's clearly one peak. It looks like looking at Mount Hood or something, so we're going to call that unimodal. Now you look, is it symmetric or skewed? Well, the median is right in the middle, the 50th percentile, so 50% of the data would be over and under. Is there really a bigger tail on the right or the left? You're like, well, no, this is not exactly symmetric, but the tail on the right and the tail on the left are very similar looking. So that's where you say this is roughly symmetric. And same thing here for the adult Irish soldiers in America. It looks like it's unimodal. Whoops, formatting. But is this one roughly symmetric? You're like, well, no, all the bars on the left seem to be taller than the corresponding bars on the right. This one's higher than this one, this one's higher than this one, this one's higher than this one. So you might ask yourself, is a tail on the right or the left? Well, the tails are about the same width, about 6 inches on each side. But this one, the bars are higher. That means if the mean starts off at the median, these bars are going to pull the mean down. So the mean is less than the median, which means this is skewed to the left. Let's look at lawyer salaries, which I got from this webpage, and I'll post the link on D2L because it's kind of an interesting article to read. But you can clearly see here, this is starting salaries of lawyers in the class of 2018. You can clearly see there's a lot of people down here between 50 and 70,000, maybe a little higher, a little lower. Not as many people in these middle range salaries. And on the upper end, there are a bunch of people who are around 180 or 190,000. So you need to be a little careful with this data because the vertical axis here is not labeled. It goes 0 to 16. So is this number of people? In other words, were there 14 people who had salaries of exactly 190,000 and 0 who had 185,000? The fact that lawyer salaries, starting salaries anyway, are bimodal is pretty well established, but you think if you took a different random sample, it might look a little different. And of course, these are reported salaries. So who's going to report their salary? Are people who make a lot going to be more likely to brag about it than people who can't find a job making anything? Maybe, but maybe not. Like, we just don't know. So either way, you definitely describe this as bimodal. And now they went ahead and put the mean and, adjusted mean. I don't know what that means. But let's just move on. I don't know if this is symmetric or skewed because it's unimodal. Let's look at some of our February weather data. So starting off, we had our precipitation data from our Februaries, where you can see there is, this bar doesn't show up like we talked about before, but there is a very strong tail on the right. So this one is unimodal because there's one well-defined peak. You can't have less than 0 precipitation, so it kind of cuts off here. But there's a very long tail on the right, which makes it skewed right. Our temperature maximum data is unimodal because there's one well-defined peak. You think, oh, well, it goes a little down here, but like if you're climbing a mountain, and you go down a little bit, you're still on the mountain. You know, it doesn't matter if you go up a little bit after that. So I'd still describe this one as unimodal. Is it skewed right or left? Well, you have a little bit of a tail on the right, but you have a bigger tail on the left. So I'd say this is skewed left. For the temperature minimum in February, again, this looks pretty unimodal, one peak. The mode is the highest point, so something here around 36 or 37. The tail on the right and the tail on the left look similar, so you might say this is roughly symmetric, but you can always hedge yourself a little bit in stats class. So you say maybe a little skewed left. Skewed left would mean cold days are a little more likely in February than unusually warm days. If you look at the rolls on a six-sided die, now this is technically a bar chart, not a histogram, but just follow me through here. If you roll a die, you expect to get 1, 2, 3, 4, 5, and 6, just as much as any other, assuming it's a fair die. You know, you don't expect to get 6 way more often than any others, but they're not obviously going to be exactly the same because this is random. So here I just did random numbers to generate random die rolls 100 and some times. You see the bars are about the same height. There's not like one big well-defined peak like there were for the other ones. And if we generate different random numbers, you can see the bars change height because it's randomly rolled, but they're always roughly the same. In some of the trials they aren't. This one's much higher than this one, but again, that's just randomness at play. So you say this is a uniform distribution. And if it's uniform, you usually don't talk about symmetric versus skewed, but if you did, you might say uniform distributions are symmetric just by their nature. So there are several left-skewed distributions in the world. The number of good eggs in a carton, if we had data on that, most of the time there'd be 12 good eggs in the carton, but sometimes there'd be 11 or 10 or 9, so you'd get something with a tail on the left. The price of a book, like if you just think about buying a book, no one's going to sell it for more than the cover price, but some places will discount it more and more and more, so you get a bit of a tail towards those lower prices. Retirement age is often left skewed because a lot of people retire at 65. There's a little bit of a tail older when people retire at 66 up to 80, but then there's a bigger tail on the left because a lot of people, well, if they're very lucky, get to retire at 40, 45, 50, 55, and so on. And here's another interesting plot. Age at death. The source for this I didn't even list. It was like some Stack Overflow post, so it's not super reliable. But I think it comes from real data. But you can see age of death. A lot of people in Australia in 2012, life expectancy, or maybe this was actual deaths. 80 looks like the most common. But then there's a tail on this side, a tail of tragedy. And of course, the biggest tragedy is down here with your infant mortality rate, which explains this spike at 0. So you could almost describe this as bimodal, but most of the time when you look at life expectancies, they exclude this because it messes up the data otherwise. All right, so that's it. You might go back to the definitions in the first place. Make sure you write these down and make sure you have them like down cold because we're going to use them a lot this term.